Hello everyone. In today's video, we are going to speak about the 5G uplink HARQ timing. Just to quickly recap, the uplink HARQ timing, this means whenever the user receives a downlink transmission or a downlink data, usually the user need to reply either with acknowledgement, ACK, or either NACK, right? Like for example, to acknowledge that he received this data, or to send a non-acknowledgement that I didn't receive this kind of data. So this is needs like a resources and uplink, especially for the PUCCH, to respond with the uplink HARQ timing, uplink HARQ feedback. So actually in the FDD system, especially for the 4G FDD, the uplink HARQ timing was fixed. But when it comes to the 5G, this changes because of the TD operation, which is, as you know, it doesn't have a separate uplink and downlink frequency, and also because of the low latency requirement in 5G. That, as you know, the 5G is a low latency design system. So the 5G introduced actually two methods for uplink HARQ feedback, which is called flexible timing. As you can see, for example, this picture will explain in details that how the user will be replying, how the resource will be allocated, and this is like the flexible HARQ timing in general can help in the low latency applications in case if you would like to instruct the GMB trying to instruct the user to send the feedback as much as fast as possible to improve the latency and so on. And all of this mechanism. And the second one, it's also kind of flexible, but it's called uplink HARQ multiplexing. This will also be discussing about it in this session. Then also I will take you through some real log traces, which showing the downlink control information DCI traces, showing how the resources are being allocated and how the users are reading the information from the layer 3 matrices, and also based on predefined 3GPP tables and the mapping between both of them. And in general, the uplink HARQ timing, this allows the network to optimize the feedback delay depend on the system configuration, the UE capability. Also, I will be addressing some of the UE capability challenges. Yeah, so let's move forward and see what we have today. Now, this is one of the most important part about the HARQ, because from this you can estimate how much it requires from the HARQ or from the receiver to send the feedback, and also you can estimate how much time required for 5G to do the retransmission. Because at the end, 4G is different than the 4G in terms of retransmission. Time is not fixed. In 4G, it was almost fixed as a transmission or a feedback time. It was knowing when the UE is going to send the feedback. But in general, as you know, assuming now that you have the transmitter sending some data, so the receiver or the device in general require a defined uplink timing for acknowledgement transmission after the downlink reception. For example, the receiver need to know when he's supposed to send the acknowledgement or non-acknowledgement and the uplink. For example, if you're assuming that this is for downlink HARQ, so the receiver need to know what is the uplink HARQ timing. So there is actually two methods or two types of the uplink HARQ response or feedback. So the first one here, it's flexible. As I mentioned, 5G in general is flexible. Flexible means there is no fixed time to be used by the receiver to send the feedback. For example, let's assume in 4G before it was fixed. Meaning what? That you know that if he received it in the slot number 1, he should send the feedback after 3 slots, for example. This was fixed, like 3 symbols or 3 slots you need to send the feedback after. In 5G, no, it can be 1, it can be 2, it can be 3, it can be 4, depend on the configuration, which I'm going to cover it in details in the next slide. So let's first see an example from the flexible uplink HARQ ACK and NACK timing. So assuming now this one being the first one transmission at very slot, so he will receive a parameter called K1 telling him that the offset to send your feedback after 4 slots. For example, 1, 2, 3, 4. So you need to send it in the slot number 4 after the first one. So you know that, okay, and now I need to send the feedback here after 4 slots from this starting point. So 1, 2, 3, 4. So you know once you receive this parameter. Then the second one here, it receives again additional one, which is called 8. So it knows it will not send it in the first uplink chance. No, it needs to send it in the K1 after 8 slots. For example, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And this is assuming slot configuration DD 4 to 1. Okay. Then again, for the last one here, it will again receive this parameter as key1 equals 7. I will show you also a real example from the traces, how this can be done, how to map it, and so on. But again, this is the main differences compared to the 4G. The 4G, it was like in fixed timing. Here, because first of all, this TDD cannot be fixed timing, and in 5G in general, it's flexible. So as you can see, sometimes it can be very fast, sometimes it can take a longer delay to send the feedback. And I will show you how to estimate what is the minimum and the maximum time requirement from the logs. So this is actually what it means by flexible. Flexible means that the acknowledgement or the feedback in general can be sent at any time defined by the network, and this information will be delivered to the UE in the RRC message and through the DCI information, as I will show in the next slide. The multiplexing uplink HARQ timing, this is still flexible, but just this means that, for example, you have three transmission here. This means all these three transmission can be multiplexed at the same uplink timing. For example, if you look into here, the D1, the first three transmission, all of them being multiplexed and sent at the same time. But there is some consideration from the GNB side, because it knows all of them is coming at the same time. This means all of them is transmitting at the uplink at the same time. So the GNB need to take care of the PUCCH resources to avoid a collision in the acknowledgement term of resources. For example, not to let them all of them use the PUCCH information or PUCCH frequencies. And this is like from the scheduling point of view, this is done through the PUCCH resource indicator for each of those users, or for each of this, for example, feedback being sent. It will assign one of 8 RRC configurations to tell them, please send it here or there, and so on, because at the end, all of them will be sending at the exact same time. So need to avoid this kind of resource conflict and so on. And whenever you have this kind of multiplexing, many of the HARQ being acknowledged being sent at the same time, this requires the different PUCCH format. For example, require PUCCH 2, 3, or 4, because PUCCH format 0, which is the normal one which is being used usually, can support maximum 2 HARQ acknowledgement at the same time. This is just a quick information about that part. Here is just the bottom left here. This is just showing the layer 3 parameters which can be identified. This one will be showing details in the next slide. But one very important information I need you to know about it as well, very, very important. It's actually about the UE processing time. You might hear about that before. That, for example, if the UE receives the information downlink, he needs some time to start processing the data. For example, let's assume the UE need 2 milliseconds. This means this one must be more than 2 milliseconds. So there should be like some kind of information known by the network and by the UE for the UE estimation time. For example, if you look into the standardized table here, bottom left here, you can see that the minimum baseline for the UE processing time, for example, he needs around 0.5 milliseconds to start to be able to process. This means this K, for example, at this particular scenario, should be at least in terms of FDD can be one slot, because at the end is 15 kilohertz, so it can be one slot. One slot will be 1 millisecond, so it can send directly in the next one, as an example. In the case of 30 kilohertz, it can be directly in the next one, because it's open 6 millisecond, or it should be at least 2 slots, because at the end the user require 0.5 millisecond to process the data. And if you compare this to LTE release 8, as you can see, this is a significant differences and improvement in 5G capabilities devices. The user used to have wait for 2 milliseconds to be able to process the data. So this means he will do the acknowledgement after maybe more than 2 milliseconds. And this is actually not good for the network latencies. And this is actually one of the additional in 5G compared to the 4G in terms of device. Now let's give a very good information from how you can get this information from a network to be able to estimate the acknowledgement time, and also you can even estimate the retransmission from this kind of information. And if you have a drive test logs, layer 3 messages, and also this information being seen, how you can correlate and know when the user will be receiving and when the user will be sending the acknowledgement for the downlink data and the uplink. Let's see next slide, which is very, very interesting. Okay, in this slide, actually, I give different information. First of all, in the previous slide, I forgot to highlight, but there is one parameter called downlink data to uplink acknowledgement, the one highlighted here in this area. Okay, this is telling the user like what is the time intervals he have to wait until he send the feedback. For example, after 4 slots, 5 slots, two slots, like acknowledgement and so on. So actually, this is mapped into a specific table. So this is how we're going to explain here. How the user will know the timing of the uplink. Assuming now in the bottom left, the bottom down figure here, you have some transmission downlink, and this is your frame. Your frame is working as A2 from the user perspective. So whenever the user receives, for example, data at slot 3 or 4 or 5, you need to know he's going to send the feedback here or here or here and so on. So what will happen? Initially, there will be scheduling information being sent in the DCI format 11 in downlink, the downlink control information. As you can see, this contains a lot of information. The most important information for us for the meantime is, for example, this is my numerology, 30 kilohertz, fine. What I need, what is my HARQ process? This sending, for example, in which HARQ process ID, because at the end, whenever the user is going to communicate, he also need to communicate the acknowledgement and acknowledgement for a specific HARQ to avoid any confusion between the GNB and DB. So this information must be noted. Also NDI, this is also one of very important information. If this one, for example, for the initial transmission was 0, then it's toggled to 1. This means that this is like to differentiate, to let the user know whether this is a new transmission or a retransmission. So for example, in this case, it was 0. This means this is a new transmission, it's not a retransmission. So in some cases, this one might indicate that this one is a retransmission to the user to let him know that this is not a new data. No, this HARQ process is just a retransmission. The most important is this one, BDCH HARQ feedback time indication, which is the same parameter here. For example, here, this one is consisting of 3 bits. Okay, so initially the user will be receiving. So assume here you have a slot 4, which is this one, in the bottom left here. And this information is 1, okay, which is mapped to coming as 3 zeros, okay, 3 zeros. 3 zeros telling him, please go and check this one against 3GBP defined table. This is information known by the UE. So he will check these 3 bits, all of them is 0. What he will go, he will first go and map this information to the 3GBP table. And you can see that in 3GBP table, defined this from first value till 8. So it's having 8 values here. So it's telling him that 3 zeros, this will be the value number, the first value provided by downlink data to uplink acknowledgement. For example, as I mentioned, this parameter will be delivered in the RRC. So in the RRC message on the left side here, you can see within under the downlink data to uplink, you have 1, 2, 3, 4, 5, 6, 7. So you have 7 values, okay, and like in sequence as you can see here. So till now the UE doesn't know this slot 4 should be send the feedback when. So once he got this one, which is 3 0, he will go and check for 3GBP tables. He will find this 3 zeros is referring to the first value. It's telling him, take the first value. This will be your information to be sent in the uplink. How? Let's see. The first value here is saying 4. This means you need to send the uplink for slot 4 after 4 slots from slot 4. So now we can, let's see, slot 4 down here, it will count 4 slots. 1, 2, 3, 4. So the uplink acknowledgement should be sent in this particular area. If you look into here, it will be like that. Second one, if you look into it, for example, slot 5, which is the next one here, is telling him this will be at 110. So it will go against 3GBP tables for 110. This is telling him that this is the value number 7 in the RR serial configuration message. It will go here, it will tell him, okay, fine. This is value number 0 after 12 slots. This means slot 5 will send the feedback at the very end of the frame, as you can see here. This is long delay here. So you can see this is 12, so it will count 12 slots. So it will know it will be sent, for example, in a special slot, which is dividing of downlink and uplink. And we repeat the same information, 010, coming at the third value, telling him go and take this one, 6. So slot 12 will send slot 12, which is here. It will send after 6, which will probably it will be the very end here. We'll map it here, then it will be sending at this one. 1, 2, 3, 4, 5, 6 here, as you can see. And the same for last one. It's again 001. If you look into here, referring to the second value, so it will mean after 5 slots, it means that slot 14 will send 1, 2, 3, 4. So again, it will be sending at the last one here, which is slot after 5 slots. It's 5 values, so 1, 2, 3, 4, and 5. This is how it goes. But what maybe it looks complicated, maybe you don't need all this information, but what you need to know that from the RRC message, you will know that the minimum time to send, for example, in this particular case, in case of your frame is 8 to 2, the minimum time, and you have 13 kilohertz, the minimum time to send the feedback is 2 milliseconds. right? 4 multiplied by 0.5, 2 milliseconds. And the maximum time is 6 milliseconds. So sometimes you only to send the feedback is 2 milliseconds. This means your retransmission can even take up to 4 milliseconds, and sometimes even up to 12 milliseconds or 6 milliseconds or 8 milliseconds, because at the end, this is just to send the initial ACK or NACK for the initial packet. So assume that you got a 12. This means after 6 milliseconds, 12 multiplied by 1.5. So this means you need 6 milliseconds just to send the feedback. So in this case, you're expecting to have even a delay in the retransmission and so on, because actually you have a long time to send the feedback. So this is, you can just indicate the time of that you require to send ACK and NACK messages in the uplink. And I believe this is very, very important in case if you want to calculate the retransmission time to do your designing for the timer and so on. Now let's move to the next, see what we have still. But before moving next, just to highlight the uplink acknowledgement in general. This is can be sent also through a PUCCH, okay? But this is controlled through other parameter called key2. So probably this will not using most of the time. It can be used, but the most common one is PUCCH, as we just explained here, and this is through parameter called K1, okay? As we just explained here.